Hi everyone, welcome back to our YouTube channel. This is Veena Nair, Master Teacher of Chemistry. We already completed properties of acids and bases. Now we move on salts. Chemicals from common salt. We have already learned that salt formed by the combination of hydrochloric acid and base. Look at this sodium and chlorine, they react to form NaCl plus water. That I already learned that which one acid react with base gives salt and water. They say this salt we are using in the food. And one more thing, another way it is there, we are getting the salt, that is seawater. Seawater contains many salts dissolved in it. Sodium chloride is separated from these salts. That deposit of solid salt that are found in several parts of the world. These large crystals are brown color. These large crystals we are getting as brownish color. That brown color means, what is the meaning of brown color? That is impurities. So that type of salt is known as rock salt. This common salt is an important raw material for various materials of daily use. So which are the materials? First one, it is caustic soda. Second one, baking soda. So many sodas are there. Third one, washing soda. Fourth one, bleaching powder, etc. We are going to study in detail about the preparation of caustic soda, baking soda, washing soda and bleaching powder, chemical formula uses. Now the first salt, caustic soda. We are going to study about the caustic soda. What is the chemical formula of caustic soda? NaOH. Chemical name, sodium hydroxide. We already know that it is a base. Sodium hydroxide is a highly reactive base. What is the chemical name? That is a caustic soda. Sodium hydroxide is a caustic soda. Now how it manufactured or how it prepared? When electricity is passed through an aqueous solution of sodium chloride. Aqueous solution of sodium chloride. That means sodium chloride we added in water. So that is known as brine. So simply we can tell it as the salt, common salt dissolved in water. Otherwise salt dissolved in water, that is known as brine. It is decomposed to form. Like this they decompose. Hydroxide also decompose. NaOH they form plus chlorine gas plus hydrogen gas. Like this it get. This chlorine gas deposited at anode and hydrogen gas deposited at cathode. And NaOH deposited in the neutral cylinder. Look at that name of the process. Chlorine is there. So it is chlor. We are writing as chlor. And base is there. So alkali. So chlor-alkali process. Chlor-alkali. From this product only we can write the name chlor-alkali process. Another method is also there. In our laboratory we can do it. Take a dish or a beaker, large beaker, insert two rods we need. One it is cathode and another one it is anode, and connected with a circuit, 6 volt battery or a 12 volt battery, and complete this circuit and add sodium chloride here, that is aqueous sodium chloride, that is brine. And one more thing, you need a test tube, cover with this rod. Take a test tube and cover it like this and press the key. What happened? Pass the electricity. At that time we can see that chlorine gas is deposited at the anode and hydrogen gas deposited at the cathode. Like this it is deposited. And one membrane is there, it splits like this, they form NaCl, like this, Na plus goes like this and Cl minus like goes, and they are depositing in this way. This method is known as chlor-alkali process. One more thing, how we can carefully remove this test tube. We get one test tube hydrogen gas, in another test tube chlorine gas, anode chlorine gas. Second raw material, bleaching powder. Its chemical formula. Chemical formula CaOCl2. So how can you give the chemical name? Calcium. O means oxygen. So oxychloride. Calcium oxychloride. That is a chemical name. Calcium oxychloride. CaOCl2. Then how can you prepare this bleaching powder? Then we already got the chlorine gas. Pass this chlorine gas through the Slackett line. The Slackett line means main thing we have to remember, that is dry Slackett line. Dry is very important. Pass this chlorine gas through a dry Slackett line, we get calcium oxychloride, that is bleaching powder plus water. So how can we prepare bleaching powder? Pass this chlorine gas through a dry Slackett line, we get bleaching powder, that is calcium oxychloride plus water. Simple one. Now it is you going to study the uses of this one. The first one, this we are using for bleaching cotton and linen industry. Linen textile industry. Cotton and linen textile industry, we are for bleaching this one you are using that. Second one, it is that we are therefore bleaching wood pulp in paper industry. Third one, it is a good oxidizing agent. And the fourth one, bleaching powder, we already know that disinfecting drinking water to make the germs free. That is the fourth uses. Disinfecting drinking water to make it free from germs. And the fifth one, we are bleaching powder means already know that we are bleaching the washing clothes in laundry. We are washing clothes in laundry. There are 5 uses are there. First one for bleaching cotton and linen in textile industry. Next one for bleaching the wood pulp in paper industry. And the third one, it is a good oxidizing agent. Fourth one, disinfecting drinking water to make it free from germs. And the fifth one, bleaching washing clothes in laundry. Third salt, that is baking soda. What is the formula of baking soda? NaHCO3. What is the chemical name of baking soda? Sodium bicarbonate or sodium hydrogen carbonate. Anyway, you can write sodium bicarbonate or sodium hydrogen carbonate is the chemical formula of this baking soda. And the process name is there. So that is name it is known as Solvay process. Or one more it is there, ammonia soda process. So now let us study the preparation. How we prepare? Look at the name, ammonia soda process. In this old salt, NaCl is the major ingredient. Sodium chloride is the major ingredient. So here we are written as sodium chloride. And ammonia. Next one it is ammonia, NH3. And soda water. 9th standard also we study soda water means carbon dioxide plus water. That is soda water. Now look at that. This sodium chloride splits to form ammonia. That is this chlorine splits to form ammonia to form ammonium chloride. That is NH4Cl. Ammonium chloride. And sodium is there. And in the water, hydrogen is also there, and carbon dioxide gas is there. We already know that wherever carbon dioxide gas is there, the product is carbonate. They form NaHCO3, carbonate. They form carbonate, sodium bicarbonate or sodium hydrogen carbonate. This is the method. And in the way, this ammonium chloride is highly soluble in water. And what about this sodium bicarbonate is sparingly soluble in water. Hence, this sodium bicarbonate or baking soda separate out as solid. It is filtered and dried. Like this way, we can make it separate out the baking soda. After dried, we get a white powder. Then we already studied. It is this baking soda. This baking soda is commonly used in our kitchen for making tasty and crispy pakoras. Also another one we are using in the cake. We added in cake or bread. That is the uses where we are using. First one, it is used in making cake and bread. Why we are using this baking soda for look at this. This baking soda, sodium bicarbonate, baking means heating. What happens? It splits to form sodium carbonate plus carbon dioxide gas plus water. This carbon dioxide gas releases. This carbon dioxide gas causes the bread or cake to make them soft and sponge. This carbon dioxide gas make them sponge. Soft and sponge. Look at that cake or anything, bread, it is there. So when we baking means heating. What happened? The carbon dioxide gas is releasing like this. So many holes we can see that. So that is carbon dioxide gas releases out and they releases out. So they form a holes over there. So that is that reaction. So first uses, it is this carbon dioxide gas. During this reaction, it causes bread or cake to make them soft and spongy. Second uses, that means it is also a major ingredient of antacid. We already studied antacid. Antacid is a base. So sodium bicarbonate is a base. So this antacid, when we feel the stomach pain, at that time we are using that medicine, that is antacid. What happens? It neutralizes our acid in our stomach. So that is a major. So sodium bicarbonate is the major ingredient. And third one, it is used in soda acid fire extinguisher. Soda acid fire extinguisher. These are the three uses of baking soda. Fourth, that is washing soda. And fourth salt is washing soda. How we prepare this washing soda? The recrystallization. Another one, it is washing soda. The formula, it is Na2CO3 10H2O. Na2CO3 10H2O. What is the chemical name? There is a chemical formula. Na2CO3 10H. Chemical name, it is sodium carbonate decahydrate. Washing soda, chemical name, it is sodium carbonate decahydrate. Deca means 10. So sodium carbonate 10H2O. So we will study our next topic, where what is the 10H2O, what is the meaning of that, what is the water of crystallization. So how we prepare this washing soda? Recrystallization of this sodium carbonate. Sodium carbonate, we have to recrystallize it. That means we have to add 10 molecules of water. We get Na2CO3 10H2O. Simple method it is. Like this we have to prepare it. Recrystallization of sodium carbonate. We get washing soda. Now uses. It is used in glass, soap and paper industry. It is used in glass, soap and washing soda means we already know that it is used for washing purposes. So it is used in soap and paper industry. Another one, it is used in the manufacture of sodium compounds. Sodium compounds such as borax. That you will study in higher class. What is borax? It is in the manufacture of sodium compound just now. And next uses, it very important use. It is used for removing permanent hardness of water. Permanent hardness of water. Some places the water is hard water, so it is have to remove the permanent hardness of water. And last one, it is a good cleaning agent. It is a good cleaning agent. So what are the uses? It is used in glass, soap and paper industry. It is used in the manufacture of sodium compounds such as borax, and it is used to remove permanent hardness of water and used as a cleaning agent. Next topic. Are the crystals of salts really dry? These salts are really dry. So we can see the two types of salts, that is hydrated salt and anhydrous salt. Anhydrous salt. So hydrated salt means, suppose we are taking the salt as copper sulfate. This copper sulfate we can see like this, in CuSO4 5H2O. It contains 5 molecules of water crystallization. that 5 molecules of water crystallization. And another cases it is same. So washing soda we study Na2CO3 10H2O. In the sodium carbonate it contains 10 molecules, fixed molecules, 10 molecules of water crystallization. Or FeSO4 7H2O. In the iron sulfate it contains 7 molecules of water crystallization. This is the chemical formula. This one formula, this is we call it as one formula unit. This one formula unit of salt contains, look at that, this one formula unit of salt contains 5 molecules of water in the copper sulfate, 10 molecules of water in the sodium carbonate, 7 molecules of water in the iron sulfate, etc. So this, how can you explain this one? In the one formula unit of salt contains fixed number of water molecule, that is known as water of crystallization. So water crystallization, how can you define a water crystallization? The fixed number of water molecules. Look at that, fixed number of water molecules are there. Fixed number of water molecules present in where? One formula unit of salt. Fixed number, look at here, 10 molecules of water. Fixed number of water molecule present in one formula unit of salt here also. What about anhydrous? Anhydrous means simple, we are writing copper sulfate, Na2CO3. These are all anhydrous salts. So there is no water of crystallization. That's the difference between hydrated and anhydrous salt. Another case it is CaSO4 2H2O. And CaSO4 half H2O, that means gypsum and plaster of Paris. Now we will study about this gypsum and plaster of Paris. The last topic, plaster of Paris. What is the chemical formula of plaster of Paris? CaSO4 half H2O. What is the chemical name? Calcium sulfate, half means hemihydrate. Calcium sulfate, hemihydrate. That is the formula of plaster of Paris. Very important. How we are preparing. CaSO4 2H2O, that means gypsum. Gypsum on heating at 100 degrees Celsius or 373 Kelvin. Very, very important in the case of temperature. It is 100 degrees Celsius or 370. 100 means 273 plus 100 is equal to 370. Convert into Kelvin. That is plus 273. We are writing 373 Kelvin. Anyone you can write it. 100 degrees Celsius or 373 Kelvin. On heating, we get gypsum CaSO4 half H2O plus, and 2 it is there. So 1.5 water molecule expelled out. 1.5 water molecules. This is known as plaster of Paris, POP. Plaster of Paris. Gypsum on heating 100 degrees Celsius or 373 Kelvin, we get gypsum. We get plaster of Paris, and 1.5 molecule water it is expelled out. That is how it is the chemical formula. CaSO4 half H2O means hemihydrate. And uses. In medical science, it is used for setting the fractured bonds in the right position. We always seen that some people fall down anywhere else. That again we have got in the hands there fracture is there. So what it is that fracture, white color fracture, that is a plaster of Paris. So and another case it is we have to use statues, toys, decorative materials, cosmetics, jewelry, etc. Another cases to making the surface smooth, that of walls and ceiling. We already know that in our home the ceiling that is we are decorating, that is there we are using that one. These are the uses. For main uses in the medical science, it is used for setting fractured bones in the right position. Second, toys, statues, decorative items, then cosmetics, jewelry, etc. These are the uses. Thank you. This second lesson completed.